Hi, I'm here with Joseph Notaro from ON Semiconductor, and ON Semi has launched a new power product family for automotive. So please tell me, what is VE-Trac?
Thank you, Ralph. So VE-Trac is our new product family. VE stands for vehicle electrification, TRAC for traction inverter. So these are solutions addressing the traction inverter part of an electric vehicle. And we have basically different products in this family, but they're all aimed for traction inverter applications. It could be chip and discrete type products. It could be transfer molded dual-side or single-sided cooled packages. It could be a gel-filled package, and it's the drivers that drive it. So it's a complete family covering all power levels from 400 to 800 battery voltages. It's AQG324 qualified, and you can have different options. You could have silicon IGBTs, silicon diodes, silicon carbide MOSFETs, silicon carbide diodes. So it's a mix and match, having the best solution for the best application.
So ON Semi has announced to start manufacturing on a 12-inch wafers for power. So please tell me more on why is ON doing this and what is the roadmap?
Okay, so ON announced in Q2 the acquisition of a 12-inch fab from GlobalFoundries. This is based in East Fishkill, New York. And the main driving factor is the huge increase in power requirements coming from the market, be it industrial, be it automotive, or be it 5G cloud power computing. So all these applications require large power die, and large power die means you need many wafers. When we look at automotive specifically, I'm responsible for, you're looking at very large IGBTs for traction inverter. You're driving 800 amps, so you need large die, or you need also large diodes. So the requirements that are going to be coming for electrical vehicle market that's growing, it's going to be many wafers are required for a single car. So we want to make sure we have the right capacity to support the growth we expect in this market.
Talking about automotive, this is going to be the main driving market for silicon carbide devices. So what is ON Semi doing to get a good share in this silicon carbide market?
So silicon carbide is part of our strategy. It's part of the VE-Trac family, so for traction inverter. But also we see many applications like OBCs and DC-DC converters that require the higher switching frequency. We have a strong manufacturing heritage. So for sure, one of the key differentiators we will have with our competitors is a strong manufacturing strategy, make sure we could support this and give independence to our customers. But also from the packaging point of view, to be able to have packages that exploit the advantages of silicon carbide, that allows the customers that they could reduce the bill of material and be more successful in the market.
One other topic you mentioned in your presentation is autonomous vehicles. So there are a lot of difficult challenges to make such vehicles autonomous. So how is ON Semiconductor addressing those challenges?
Well, there's challenges coming from the technical side and challenges coming from maybe legislation. And the third challenge that we see is coming from user acceptance. The user has to start gaining trust in the autonomous vehicle that's driving. So from the technical side, we're addressing this by investing in all sensing modalities. We are number one in ultrasonic sensor interfaces. We're number one in image sensors. And we are investing also in radar and LiDAR. Each sensor has its own capabilities. It has its own strengths and some weaknesses. You have to make sure when you have an autonomous driving car, you want to trust it completely. So you want to make sure that you have functional sensing in every single situation. And then it's how you treat the data. So we're working with our partners, the CPU partners that are doing the main computing, to make sure we provide the right data with the right bandwidths and to make sure that the information that we provide is useful to them and vice versa.
So, Joseph, thank you very much for this interview.
Thank you, Ralph. It was a pleasure meeting you.